we concluded the last time. But I've given the note to the slides to Shitu, and I give to the other man, Vincent, as well, to give you guys. So you can also go through that. But maybe before we say anything on that, I would like them to be around first. So for today, we are looking at developing project network using PERT and CPM. Developing project network using PERT and CPM. And then we are also going to see network analysis. The bottom line is that both of them require you to draw to analyze whatever you are the project using network analysis. Please, somebody's mic is on. Just put yourself muted. Make it muted, please. So, introduction to project network development. So we said a project network is a graphical representation of project activities. A project network is a graphical representation of project activities, showing the sequence in which activities must be performed. When we say sequence, if one activity A, for example, you have 5 activities, activity A, B, C, D, and E. Each one must occur before the other. Okay? This
Please turn off your mic, please.
Cooperate with me, please. If you come here that you want to learn, then you follow the rules. Just be quiet. If you know you want to do other things, then don't come at all. Don't come. You are burning your data and you are disturbing others. I don't want to mark anybody down. Okay, so what is the minimum time required to complete the project? All of this is what your network project or your network diagram, your project network rather, will help you as a manager to be able to see. So 2 major techniques used in developing project networks are program evaluation and review technique. That is the acronym I mentioned earlier, PERT, program evaluation and review technique. I'm going to explain all of this. I'm just giving you this as a background. Maybe tomorrow, I spoke to Vincent. I will still create time for you guys again, and we agreed 5 p.m. By 5 p.m., this class can continue because I try not to be too fast and not to be too slow. I'm always conscious of the fact that you might have another lecture after now. So please, let's just work together. So these are the 2 key techniques when you are trying to develop project network. And I'm going to show you how they differ. Now, the meaning of PERT. We say PERT, Program Evaluation Review Technique, is a probabilistic project scheduling technique used when activity durations are uncertain. That is why we say it is under probability. We are not so certain of the time, the project or the activity, the time required to complete each activity within the project. It is the activities within the project that will determine the project completion time. So if you are not sure of the time required to complete an activity, then when you are drawing such, you have no other option but to apply this, follow this approach when you want to draw or develop a network diagram. So we say PERT is a probabilistic project scheduling technique used when activity duration are uncertain, and we use 3-time estimates to calculate expected activity duration. Not project duration per se. We have to know the activity duration. It is the duration you spend in each activity that will determine the overall time you spend on the project. So PERT is particularly suitable. Please, all these things I'm saying is what you will see in the exam. Oh. I'm not used to say you want to do more pop, whatever. You have the opportunity now. There's no magic anywhere. I'm not going to ask anything outside of this. But if you don't follow through now, you are waiting that maybe later. You have the time now. As I'm saying it, go through it. Try to understand me. So PERT is particularly suitable for research and development projects. You will see something like this in the exam, no doubt. I'm telling you now. Okay. 2, it is also suitable for new or innovative projects. Number 3, it is suitable for projects with high uncertainty. So research and development, most times we don't know where it's going to end. There are many research that has been going on for ages now, yet we've not come to a logical conclusion. So such kind of project and some research that we even carry at the end of the day, we disembark. When we meet some kind of bottleneck that we see that this research is not heading to any meaningful or logical conclusion. So what we are saying in essence that once we are not certain about the activity, about the journey, about the project we are embarking on, we want to draw or develop an analysis diagram or a network diagram, this is the approach that you follow. Okay, new or innovative project. These are projects that you don't really know how they are going to end up because they are new. It's not something anybody have done before. You have no idea about it. So there's largely, so this common thing about this, the central word there is uncertainty. Once there's uncertainty in the project or in the activity, you have followed this approach. And the 3-time estimate are usually 1, the optimistic time. I want to believe you all know what we mean by being optimistic. We say the best case scenario. The best case scenario. Against all odds. We want to be positive. Okay. We also have the most likely time, which is the base case. The base case. This is the normal expected duration that we expect the project to get or the activity to get completed. Okay. And finally, worst case scenario, which is the pessimistic time. So they have been designated A, M, and B. A for optimistic time, M for most likely time, and B for pessimistic time. Now, you have the expected time formula to be A plus 4M plus B divided by 6. You may be asking that why is it 4? Why is it that 4, we have 4 attached to M? Because those who brought about this formula from the US, to be more specific now, the US military, from the argument which I align with, what is most likely to happen have a greater chance of happening. What is most likely to happen have a greater chance of happening than what is what you look at the 2 extreme, whether being optimistic or being pessimistic. And by their estimation, they say it is 4 times likely that this thing is going to happen. So, and then how do we come about the 6? If you have in mathematics, you always will say when you have an integer or you have what do I call this now? You have alphabet A, automatically you look at it that it represents 1. So 1 times A is A. So you have 1 plus 4 plus 1 times B is also B. So we give you what? 6. So you are looking at the average of the optimistic time plus the most likely time plus the pessimistic time divided by 6 will give you the expected time of completion for that activity. Are we together, please?
Please come again, sir.
Good. I said for PERT analysis, or for when you're looking at PERT approach, you always go with this approach whenever the question or whenever the situation in a real life setting now is such that you are not sure. You have a project you have not done before. You cannot say for certain that this is how the project is going to end or this is how it's going to go. You're not certain. And so because you are not sure, you have to have 3 point of views. Things can go well the way you expect it to go, and things can be worse the way you don't want it to be. But however, you have to be prepared for all possible cases. You have to factor it, and things can even be much better than you think. And so that's why we say for under this approach, we have to look at the expected time of completion of a project in looking at 3 time estimates: the optimistic time, the most likely time, and the pessimistic time. And I'm saying that for those who handed us this formula, said this is how it is supposed to be done. For the optimistic time, well, it may happen and it may not happen. For the pessimistic time, well, it may happen and it may not happen. But the most likely have the greater chance of occurrence. And from what you are saying, we are saying it has 4 times probability of occurring. So that's why you have that 4. That means we are invariably, we are saying even 4 times more than the optimistic and even pessimistic. So if we say A plus 4M plus B, when you want to sum up everything, you end up having 6, because I said A standing alone in mathematics, of which I believe you must be used to. When an alphabet or when a variable is standing alone, you assume that there is an invisible one there. So 1 times A is always A. 1 times B as well is going to be B. So we have that 1 plus the 4 times M, which is in this case now we are saying that the will I call it the coefficient now of M is 4. Y for A is 1. So 1 plus 4 plus 5. I'm sorry, 1 plus 4 plus 1, which is 6. 1 plus 4, 5. 5 plus 1 will give you 6. I'm right here. And that is how we got this 6 that you are seeing. So what this is trying to say to you is that we are looking at the average time. The expected time is also the average time. Because normally when you are running average, you have to count the entire set of items that you have, add it up, then divide it by the total number of items that you are looking at. Is that clear, please?
Yes, sir.
All right. Thank you.
Thank you, sir.
Okay. Now, for an example, we have a university ICT unit implementing a new e-learning platform.
Hello, sir.
Yes, please.
I've not still gotten that formula explanation.
Okay. Let me come here. Let me come. I said A plus 4M plus B divided by 6. This, I hope you are seeing my screen.
Yes, sir.
Yes, sir.
What we are saying here is that we are simply looking for the average of everything here. The average is what you are looking for. Normally, for example, look at, you have 2 here, you have 3, you have 8, you have 4, you have 6, you have 5, you have 4, you have 7. In statistics that you've done before, which I believe you must have done in year 1 or year 2, if they say look for the average of this, are you not going to add 2 plus 3 plus 8 plus 4 plus 6 plus 5 plus 4 plus 7? Whatever it gives you will be here. Let us just say this is n divided by what? The total number of figures that you have here. And if you count, this is 1, this is 2, this is 3, 4, 5, 6, 7, 8. N divided by 8. So,
yes.
yeah, so I said, and normally this A you are seeing here means there's an invisible one here. The B you are seeing here, you have an invisible one here. So 1, this 1 plus 4 plus 1 gives you what? 6.
Okay.
So, in other words, yes. So, in other words, what you are seeing here is A plus M plus M plus M plus M, then plus B, divided by what now? A here is 1, 2, 3, 4, 5, 6, divided by 6. That's just the idea behind that formula. Is that clear, please?
Yes, sir.
Okay, good.
Yes, sir.
So we go back to where I was before. Okay. So I said a university ICT unit. I don't know the person writing all this thing on the screen. I don't really understand why this happens sometimes. A university ICT unit implementing a new e-learning platform may not know how long system integration will take. An ICT unit they're about to set it up. And we are looking at having a new e-learning platform. And for you to set up this, you have to integrate a lot of things together, bring them together, connect them to work. There are a lot of factors that happen. You cannot say it will finish in 7 days or in 6 days. Okay, somebody put off your mic because I'm getting some feedback. So you cannot say that this is going to finish in 5 days, in 7 days, in 2 weeks, because you're not sure. Okay, take for example, today we are here by the grace of God. The only challenge I know for me as a teacher or as a facilitator I have with online teaching most times is network instability or internet rather. Once the unstable network. But however, these days it's not, most of us are online. We're on Facebook, you're on TikTok, the network must come. But sometimes it may not be available when you need it. So internet instability can be an issue that might affect the entire integration process and might delay the process of integration. You can also have issues as vendor responsiveness. The people you are calling to come and set it up for you may tell you, okay, we'll come next week, Monday. And when it's Monday, they now tell you another story. Please, oh, sorry, we'll have to make it Wednesday. So if you have already fixed the date or the completion date of your project, integrating the systems, you end up messing up your calculations because of these uncertainties. You can also have staff training challenges. The system has been set up, but we also need to train. Staff do not know how to use them. Most of the staffs are finding it even difficult to integrate. So it takes time for people to learn. So all of these things, and you cannot determine exactly when people will catch up. Okay, you may not be able to determine that. So PERT, which is PERT, helps account for these uncertainties when you are trying to draw your project diagram or when you are running a project. So therefore, we look at CPM. CPM, on the other hand, we refer to it as a deterministic scheduling technique. We know already. Then the sure banker, we are not having any doubt as to how or when the project is going to come to an end. Every activity within the project, we know how the completion time. So CPM is a deterministic scheduling technique where activity durations are assumed to be known with certainty. So CPM is commonly used in construction projects. Okay, so you begin to see make comparison now. And when we say construction, however, we have different classes. Okay, so but I don't want to go there now. Manufacturing as well, you can use CPM. You can use CPM as well for infrastructure. That is why we use the word we assume to be certain. In this life, there's nothing 100% certain, but at least there's a degree of certainty you have that you look at and say, okay, let us follow the CPM approach. Infrastructure development is one of them. The key concept in CPM is that activity, which is a task that consumes time. We have activity, which means a task that consumes time and resources. Now, these assumptions are also what you also have in, what do you call it now? In PERT. Both of them share the same thing because both of them, you have activities in both. Okay, a task that consumes time and resources. You have what we refer to as a node, which I'm going to show you. I'll show you everything. Don't just worry yourself. A node that has the beginning or end, that shows the beginning or end of an activity. Okay, you also have a path, which is a sequence of connected activities, how one activity is linked to the next. You also have what we refer to as a critical path. A critical path in project designs or network diagrams are usually the longest path through the network. The longest path through the network. I will show you all of this. Even if I don't do it today, you see, some of you say I'm too fast, I'm rushing. I just don't feel too comfortable. That's why I like to have my time with you outside this kind of tight schedule where I'm not even sure when this thing will just log me off. Okay, so we talk about the float. The float, or you can say the slack. Usually when you say slack, you are trying to, when they say cut me some slack, give some room, create some room. So extra time and activity can be delayed without affecting the project completion time. The extra time and activity can be delayed without affecting the project completion time. I said I'm going to show you all of this when I take you on the next platform. So, a Nigerian example, we have construction of a hostel building in Unilag. This involves known construction processes. We are going to maybe do what they call, what do you call it now? We are doing the foundation, the pegging or the logging of the foundation. At least it doesn't depend on external factors that are outside our control. Please give me a second, please. Give me a second. We don't have factors. Okay, I've just been told my time is running out, but I think I still have some time, so I might come back again. You might use the same link. Just use the same link and come back. So wherever it takes us, we may not finish that one. But tomorrow, let me see how many people we have here. Tomorrow, 5 p.m., I have discussed with Vincent, and I think she too should be aware as well. I will create time for you guys, and maybe we can do from 5 to maybe 6:30 or 7. At least if I get to a logical end, I'll be happy to fix another date again, maybe to conclude whatever we have been on. So we have standard durations. Construction of a hostel building in Unilag involves what? Standard durations. We know how long it will take for us to mix the cement, how long it will take for us to finish the foundation, laying of the foundation, and so on and so forth. It doesn't rely so much on extraneous factors or factors outside our control. We look at defined material requirements. Okay, we also look at, so in summary, we say CPM is ideal for planning and controlling such projects that have a determined time of completion. So the key difference, like you see here, we say the nature of time for PERT, probabilistic. The nature of time for CPM is deterministic. Time estimates for PERT are 3. The optimistic, most likely, and the pessimistic time. While for CPM, you just have 1. Look, the focus is what? Time uncertainty. Time uncertainty. That is the fear. For CPM, the issue there is time and cost. Time and cost. Orientation. We have event oriented, and here we have activity oriented. Event and activity oriented. When it's an event occurring and when it's an activity going to occur, which I'm going to show you, maybe if not today, tomorrow. I have less than 7 minutes. Now, step 1, steps in developing a project network. First of all, you must be able to identify all activities. You must be able to identify all activities. Let me take you here quickly while I am. Look at this, for example. You have this before you. These are activities. All what you have here, this activity A, B, C, D, E. Sometimes in the exam, you may have it that they will tell you what the activity is about. But for simplicity's sake, you just pointed that this is an activity. This is activity A, activity B, down to you have activity H. It can be more than that, it can be less. So you need to know all the activities involved in that project. 2, you list all tasks required to complete the project. That is, identify all activities. Step 2, you also have to understand or determine the activity sequence. Identify which activities depends on others. There are some activity that doesn't depend on others or other activity. They don't depend on other activity. They are standalone. I'm going to show you that as well. Okay, so activity that depends on others and activity that are standalone. Okay, you have to determine that. Number 3, before I go further, I want to assure you, and I'm not joking, I'm serious. For those of you who have any phobia or anything, any fear, it's one of the cheapest topics. It's very, very cheap. It's not difficult at all. So, but if you are coming to see it for the first time, and it appears somehow to you, it's normal. It's normal. But I tell you, if you spend more time, you follow what I'm explaining to you, you discover that it's not as difficult as it may appear. So put your mind to rest. There's nothing to worry here. So estimate activity duration. This will be given to you, no doubt. Okay? Depending on the situation. If it is CPM you are asked to solve, you will be given a single time estimate. If it is PERT you are asked to solve, you'll be given the 3 estimates. Now it's now left for you to now solve using the formula I showed you to get a single estimate. It's like converting PERT to CPM. That's just the key difference. So step 4 is to draw the network diagram. Step 4 is to draw the network diagram. And this here, you will represent activities and dependencies using what? Nodes, arrows. So let me quickly say that because of our time. Let me show you what I'm trying to see here. You said we represent activities using nodes and arrows. When we say a node is just this circle you are seeing. A node is just this circle. You see now, this is a node. And your activity is the arrow. This is your activity. So usually, if this is the tail of the arrow, this is the head of the arrow. You cannot draw an activity this way and stop. So when you are going to complete, to make sure that your activity, let us say this is activity A, for example, to be sure that activity A is well drawn, you must cover activity A on the other end. So for each activity, you have 2 nodes. For every activity, there are 2 nodes. The beginning node and the ending node. Okay, node 1, node 2. You may number, you may not number, no problem. But what matters is that know that every activity must start with a node and finish with a node. So I have to show you this so that you don't begin to imagine that what do we mean by nodes. Okay.
Yes. To do it, yes.
Hello, sir.
Yes, please.
The notes and the arrows that you just explained now, how do we use them?
Yes, I will show you how you use them when we are trying to solve a problem. Okay, so now I'm just introducing them to you. I'm not happy when I hear people talking and you are in a class like this. Eh? How do you feel the person will speak?
Your bag.
You,
How are you?
let me take this.
Thank you. And not in my essence.
Do Juliet 211002445. It's okay. So that's good. So like I said, when we are solving a problem, I will show you how you use the node. The node by convention is just to let you know that this is where this activity is beginning and this is where it's going to end. Is Shitu around now? Hello, Shitu or Vincent? Hello. Hello?
You're not around, sir.
The two people are not here. Okay, I'll soon go off now because I have less than a minute.
I'm not around, sir.
I want to be sure if whether I can come back again today. So just hold on. Let me get in touch with them. I'm going off now.